Sorry for the delay. Hello and welcome. Why is the music so loud? Or is it my... Ah, it's my headset that was a little bit louder than usual. Alright. Welcome. Yesterday we had a little bit of trouble at the end with like GPU crashes. Sorry, I need to set up my second monitor. Alright. Cool. And let's just open YouTube as well, even though there's rarely people watching there, but whatever. Alright. Yes, so we had some issues with the GPU crashes, and this lunch I investigated a bit. Well, I didn't really investigate that much. I was like, let's try and remove all of our triplanar shading and see if we can just output a solid color. So basically I reverted that shader and did like this shader instead. Well, we just output a solid flat color, a solid red flat color, just to bypass any like problems with like maybe divisions by zero, which are usually like crashes for the GPU or something like that. Or which can end up in crashes. And with that, if I'm not mistaken, it was a little bit better then, in the sense of that we didn't crash anymore. If I find my way back. So let's remove that, because that was another thing that I then did in my lunch break. But yeah, if we have like just a simple shader and nothing fancy going on there, then we got this beautiful thing. Well, if it continues, which is, yeah, we have a sphere, but there's something weird going on. Because yeah, as you can see, we have like missing triangles, and then we see triangles from the back, which is as well something we shouldn't see usually. So that is what makes me think that the winding order is wrong, because we shouldn't see something from the inside. So what I did is, that's not entirely how we should do it, but we can for now just add a function that ensures that our winding order is correct, and if not, we just flip it. And with that, it looks way better, but still not exactly perfect, because we still have some holes here and there in our sphere. And then I noticed as well that I wanted to eliminate a little bit like the cases, right? So what I did is, I still have a 10 times 10 dimension for the chunk. So we go from 0 to 10 in like all directions, from the 0 point into all directions by like in 10. But what I wanted to have is in the Y direction, I move my sphere up. So what that should give us is a hemisphere, right? Well, actually, maybe not. Hold on. Maybe I'm thinking about that wrong. But even then, I think it's wrong how it's visualized. Because even if it's not that, we are only seeing a fourth of the sphere, right? But realistically, we should see half of the sphere. Right? Oh, maybe not actually. Maybe that's actually not so wrong after all of what I thought it would be. So that's half a sphere, right? Yeah. But it's still, the winding order is still kind of scuffed here, right? So let's not do that. Well, actually, let's move it 3 in and 3 deep and then nothing into the 0 direction. So it should be a dome kind of thing, right? Yeah. Then we can see that there is some weirdness going on where here we have like the triangles here, but then we have some triangles. Actually, no triangles here, but yeah, some are like back side, some are front side, and some weirdness going on. So something is off for sure. And what I did is basically went away from the chunk for now and we just directly sample everything as is in place, basically. Generate the mesh and then, yeah, be done with it. But what I'm curious is, are the cubes correct? So that should be a face, and that should be the front face, so we should have a consistent Z coordinate. Probably 0 as the first one. Okay, so that's already wrong. Because we have a Y coordinates that's consistent. And that's not how it should be. How come that is the case? Why would that be the case? Okay, 3, 2, 6, 7. Zero. Alright, so and then we have, this should be the front face. So we take 3, which is close to the camera, yes. 2, which is close to the camera, that's correct. 6, which is definitely not close to the camera. And 7. Is that even a face to begin with? So 3 is right up front, and then 2 is left up front. So we have, well, let me note that down. Let's note it here. So we have right front up and then left front up. So that makes kind of sense, that at least is in the same potential plane still. And then we go 6, which is left up back, which doesn't make any sense, because with that we cannot get a plane anymore, right? Because we already have, yeah, so that is garbage. Let me double check with another lookup table that I have. Which is for this face. So we would take 2. Which would be left up back. And then we would take 0, which is left down back. And then 6 would be left up front. Does that make sense? And as long as the 4 left down front. Yeah, I think that is, so we go left up and the back, And then we go left down back, and then we go left up front and left down. That is a valid one. Now we have 1, 3, 5, 7. So that is the left face, right? Left cube face. Pretty sure. Now we have 1, which is right down. Did we do 0 as front or 0 as back? 2 back, I guess. Right down back. And then we do 3, which is, well, actually, hold on. 1. Oh yeah, right down back, and then we go to 3, which is left up back. And then we have 5, which is left down front. And that is already kind of busted then. Because we're not consistent on the side anymore. Okay, so my vertices need to be different as well. In that case. Okay, let's do one thing then. Okay, yeah. Let's take that lookup table. And I'm pretty sure that, well, if I make that correct, so that will be 206. That's the back face. That's the front face. And then we have this one, which is left face. And then here we have right face. And that is 4, 5. 4, 5, 6, 7. Hold on. That is the right. That is actually the bottom face. And that is top. And that is left. Because it follows this thing. that's more correct here. Okay, so does that make sense? Because before that, that's back, that's front. And then 5 is bottom. 0, 1, 2, 3, 4, 5. Okay, well, maybe not. Oh, wait. It's like that. So that makes more sense, right? 0, 1, 2, 3 is top, 4, and 5 auto. I mean, yeah, if you look at it from the front face, well, then technically this is left and this is right, I guess, right? Hey, Hoshi R Games. No, my engine will not be used as a plugin. That's kind of not this point of an engine, right? Although like the initial one was done in Unreal, like as a plugin, but we're not doing that anymore. But I can show you what I'm doing. So basically I'm currently looking at debugging this, which is basically generating like a mesh from volumetric data. We already had one version that was working, but I'm trying to do a different algorithm for the extraction of the surface, and that one is not working currently. So we're currently debugging that one and restructuring a little bit what we feed into the algorithm. And yeah, the plan is to have volumetric terrain. No, it runs standalone. It has nothing to do with Unreal. It's a standalone engine. You have a standalone editor. You can do stuff in the editor for my engine. I mean, you could take, as it's C++, you could take it and integrate it into Unreal. Not too big of a deal and not too hard. And let me actually quickly, while you're here, I can show you what I had in Unreal already, but I switched away from Unreal, so now I'm doing my own engine. But for that, it was running in Unreal, and I can show you what I had there. And then you see, like, that was mostly already working in my engine as well. Well, except for the foliage stuff. It was a plugin, so this is the plugin, right? So this is running in Unreal, and this was already, like, this is the old version of the surface extraction, and that was already working. I can post it here as well if you want to have a look on your own. But yeah, that was a plugin. But I moved away from Unreal because I wanted to do some graphics, Vulkan rendering on my own, like learning that stuff. But nothing in the plugin is like engine specific. No, it's a Vulkan. And the back, like the window surface is native C++ Windows implementation. I don't use SDR. I will probably move to GLFW though in the future, for the reasons of like platform support. So no, I'm not using SDR currently and don't plan to really use it. Well, even with SDL, you would create your own standalone app, right? SDL is just a framework. But yes, that's the plan. And I mean, we are pretty much already at that point, right? I have an editor running. I mean, that will probably horribly fair now. No, I will still use Vulkan. So, GLFW and SDL. I mean, SDL has like rendering as well. But realistically, SDL... I mean, okay, the SDL 3, it has like proper shader support now and everything. So I guess it's very, very close to like having an more or less engine already. But you need to still write all the stuff around it, like resource management and stuff like that. But yeah, GLFW is basically another thing similar to SDL, only that it is more bare bones, it doesn't have audio. I was a graphics engine programmer at Ubisoft, massive, and worked on Avatar, and worked as a gameplay programmer and lead gameplay programmer on Rainbow Six Siege. So not graphics back then, but then I did like 2.5 years of engine graphics programming at Snowdrop. And now I am back in my home country, so there is no Ubisoft. And yeah, still in games business, but not AAA anymore. Sure, shoot away. I'm streaming as well to answer people's questions, right? So that's another reason why I'm streaming. So it can only be that I'm answering maybe a little bit slow because sometimes I want to get stuff done here, but feel free to ask away. That's fair. I mean, yeah, that for sure. Everybody would want, or everybody wants to be productive, I guess. But yeah. What I installed to create standalone solutions. I mean, I'm not quite sure if I understand the question, but probably your best bet would be, yeah, either Unreal or Unity, I would assume, if you want to go into like games for graphics programming, because there is like scientific graphics programming as well. You have already Windows 10. Well, you need then... Okay, yeah, that's a good start, but yeah, you would need some sort of graphics engine, because you can't really... I'm not getting the sense that you have like a lot of base knowledge already, so you would need something already working. So Unreal or Unity would probably be the best bets. You could use OpenGL, but I wouldn't recommend Vulkan right away. And especially like if you go for... I mean, we can you can definitely join my Discord server as well. I think it's /Discord, right? Does that work? And then you can poke me in Discord and we can talk a little bit more. Doesn't need to be now on stream. You don't have to join. We can do it here as well, but I think it's maybe a little bit easier then. And I would not say that you should already look at like OpenGL, Vulkan, DirectX. Those are the graphics APIs. There's a difference in like the layer, right? Vulkan, DirectX, and OpenGL are like the low level APIs with which you interact with the graphics card. If you are just interested in learning a little bit about shaders, how they work and stuff like that, that's like a layer on top of Vulkan, OpenGL, and DirectX. Because those three execute shaders, but I think you're more interested for now, I would assume, in like the shader part and not necessarily in the APIs that run those shaders. But maybe I'm wrong, maybe you're really interested in the API. But then I think OpenGL is the easiest to start with. Vulkan and DirectX 12 are beasts to start with, because they have a lot of boilerplate code to get started. Alright, so those are my faces, right? Let me double check again. Zero opens up like that. One opens up like that. X and Y. I think that's wrong. I think that makes more sense because that opens up to the side here. And I think that makes as well more sense with this. So this would be left. And this would be right. I think that is more correct, though I'm not 100% sure. And then okay. So that's that, and then we need to basically move that here so that we see it. And then we need to put those in order, so we do... Or actually, let me put that here as well. This beautiful ASCII art. Is it that one? Yeah. Oh god. That's not what I wanted. Beautiful. Actually, I'm thinking either using OpenGL, Vulkan, or DirectX in develop solutions, or use available engines. So OpenGL and Vulkan are two different things, so you would need to decide. I mean, you can always implement more than one, but I wouldn't recommend that at the start. And then if I would choose between those three, either DirectX 11 and not 12, or OpenGL, because those are the easier ones to get started. But if you are just interested in shader programming and not necessarily in like the raw API usages, then I would recommend an available engine like Godot, Unity, Unreal, because all of them have like shader support and you can write your own custom shaders and play around a little bit with shaders. That's good enough to start. Because yeah, implementing like the raw API usages, I mean, you learn a lot, but I don't think it's needed, right? That's the thing that I'm like Okay, so this is 4. And then we have back, up, left is 2. And then we have right, up, back is 6. And then we have front, left, down is 1. Front, right, down is 5. And then we have left, up, front is 3. And then this has to be 5. 1, 1, 1, yes. Yeah, but for example, I mean, it really depends on the company. So there is not a specific 100% correct. Like it really depends. Like in Ubisoft, for example, there were render programmers and graphics programmers. And the distinction was a bit blurry. But render programmers were more related to the use, like the implementation of APIs like Vulkan, OpenGL, DirectX, and making sure that it runs on the platforms, and maybe adding like ray tracing and stuff like that. So more like broader graphical things. And then a graphics programmer was more, we need this VFX effect in the game, like fog, for example, or we need like a shader that does like a blur or something like that. That was more the graphics programmers. They were more on the shader side, because the implementation of Vulkan, OpenGL, and DirectX is in C++, and like graphics programmers are more on the shader side, so GLSL or HLSL, which is like programming languages for shaders. Then again, the distinction was not quite clear, because even as I was a graphics programmer, we still did some stuff on the back end of like Vulkan and DirectX, but that was more or less the separation and at Ubisoft. But in other companies that I worked for example, it was like one role. But if you use, for example, an engine like Unreal, Unity, Godot, you don't really have to deal that much with like Vulkan, OpenGL or DirectX. You have to deal more with HLSL, GLSL, because you write shaders, because most of the graphics API is already there. GLFW is a good choice, but that's just the windowing. You always have to differentiate. There's like different systems at play. Let me open that. Can I make a new? What we can do? So you have like 3 things, right? One is the graphics API, which can be either Vulkan or OpenGL or DirectX. And that is what runs your shaders, basically. And what it's basically your layer, like your layer to talk with the GPU. Yeah, sure. It's actually, because it's disgusting that it... Can I make that bigger? Man, why can I not make it bigger in... Do I have Notepad++? Okay, now then we have to deal with it, that it's red underlined, but whatever, you can hopefully deal with it. So that's one part, right? And then you always, depending on your platform, well, let's leave that out. That's a small detail, but you need... So the graphics API is just the thing that talks with your GPU. But all of those, they need a window as well. So the window is basically what Visual Studio, for example, like this thing, right? Or if I start my thing, well, probably it doesn't run now. Let me open my old compiled version. Well, I think you get it already, but just to be sure. Is it here? It probably, yeah, it doesn't run because it doesn't have the data directory. But yeah, the window is basically anything where we can draw to. It's basically a canvas, right? And that is where GLFW comes in, right? Or SDL. Or like native Windows has an API for it as well to create windows. Like I can show you in my like I'm using the native Windows version, not GLFW or SDL. So basically what you do is somewhere here, it's really not too hard, but and you don't need to remember that, but basically GLFW and SDL do the same thing. Somewhere you have to call something like where is it? Create window W. That's a Windows function, right? And then you get a handle, and that handle you can use to give to Vulkan or to DirectX to use for the swap chain to present images on the screen. So that's the other part. So that's 1, and that's 2. And then you need a third thing, which is shaders, which is similar to what you do in C++. Those are like execution units that you run on the GPU. You can think of them like executables for CPU. So for example, on the CPU, we use C++, we use Java, you use C# or whatever to create an executable. For GPUs, you use shaders, and they can be either in GLSL or HLSL written. Yeah, sure, I have time later after the stream. Don't worry. So those are basically similar to like C++ for CPU. And you need like those which run on the GPU, which run over the graphics API, and then if it's a graphics shader, you will output it to the window. If not, like compute shaders are a little bit special. For compute shaders, you don't need this second thing. Sure. Is on physical GPU hardware code inside? I am not sure I understand the question, but no, I wouldn't say that there... I mean, I'm not sure I understand it, but no, there is no code on the GPU hardware itself. I mean, you have some basic functions there, similar to like what you have for C, C++. You have like some built-in functions, but there is not really any code per se already there. But you can always check as well HLSL, for example, or like I use GLSL. It doesn't really matter. They are very, very similar. There is not really a step 4 after that, to be honest. But that's already, those 3 steps are already quite big. But GLSL is like one shading language, right? And you have like some functions, as you can see, like you have a mix, a smooth step, normalize. So you have some functions here that are like given to you for free, basically. Yes, GLSL. Native surface. Where do you read that? But I mean, the native surface is like a window, basically, like a canvas, like I said. It depends on the platform. Linux has a different surface than Windows, but usually you can get one for the operating system, or you use GLFW or SDR to get the surface. Those two libraries, one of them you can use, you don't need both, right? You need either one you can use to get a surface. But basically, as I said, it's just somewhere this call, and GLFW and SDR do the same. They call this create window, and that's your surface. It doesn't, it's not, that has nothing to do with, your graphics card has nothing to do with any of that. The only thing that your graphics card has a little bit of impact on, but nowadays it doesn't really matter anymore, is Vulkan. There is some graphics cards that don't support certain versions of Vulkan, but that's very rare, and I wouldn't care about that right now. You're not at a point where you have to care about that. All newer graphics cards from the last, I would say, 6 years have Vulkan support. So probably even more than that, probably more than 6 years in the past. So I wouldn't care about that. Because they want to make money. That's why. If you get one off the market, no, there is no step 4, not really. I mean, in theory there is a step 4, right? Bright shaders, but it doesn't really matter. I mean, those are like the main 3 things you need for a graphics engine. I would really recommend you go. I mean, that's really hard to answer because it really depends on. I don't know what you would want to, like. You say you want to be a graphics programmer, but the field is so big in that I'm not sure what to recommend. Except for I would probably go to Unreal and watch some tutorials on how to build like materials in there, because those materials are basically shaders. So you basically build like this here, because the stuff here, those two, I don't think they really are that important. If you want to create something and sell it somewhere like Unreal, then you eventually need those two. Because you cannot do something in Unreal to sell it like Unreal, right? And hello, Captain Chica. I will go slowly back to working though, but feel free to ask your question. I will answer it, of course. For Unreal Shop, I actually don't necessarily know. I would need to look that up, but I think not really anything. I think you only need the Unreal Engine, and then you can, I think you can build the assets to sell on there using Unreal. But I'm not an expert on that. But there are probably guides on YouTube or the internet how to sell something on Unreal Store. Because I bet I mean, there is already a lot of stuff in the Unreal Asset Store, right? So you will not be the first one. I'm doing this not here for like my livelihood. I work for the games business and get like money from there, right? But I'm not streaming or building this engine to live off from it currently. And I don't know. I would build something simple first, right? You said you want to do something like Unreal and sell it. That's a huge endeavor. And probably a little bit unrealistic to aim as a first project. I would start with a little bit smaller. Like you said, like do something and sell it on Unreal Store. Like a small whatever shader. Like, I don't know, build a shader for motion blur or fogs or something like that. Like a fog effect or something like that. With that you already have like quite some... fog is not that simple if you want to make it volumetric, for example, but that's only if you really want to do like something in graphics. As Captain Chica said, a Snake game is probably better. Well, that all depends. You don't really need to install that much. If you do it in Unreal, you don't have to install anything except for Unreal, and you can build your shaders in their shader graph. And it's a little bit more visual, it's easier to get into, and then once you're more comfortable with that, you can translate that to actual shader code, written shader code instead of just visual language. I think visual coding is like easier to start with, but that's maybe my opinion, I don't know. Yeah, sure, you can. I can give you some more details there. Sure, no worries. Thank you. Thank you, bye. That's corner 5. What's that? X1? Y0? Wait, that is 7. Yeah. Okay, so that works. Now we take that. Go in here. Go in here. Go in here. Have that commented out for now. And then phase 0 is a back phase. So if we are a back phase, we need X and Y. And then the front phase, we need as well X and Y. And then we are a bottom phase, and for that we need X and Z. And for the top phase, we need X and Z. And then left, we need 1 and 2, 1 and 2. That should be better, hopefully. Or it horribly fails. I mean, that looks almost as bad as before, so... But we are... Am I doing the clockwise thing? Yeah, I found one of the problems. One of the problems was that my 3-planar shader seems to have crashed somewhere. So what I'm doing now is outputting just a single color in the fragment shader. For now. We do one problem at a time, right? First I want to get a sphere up and then we see what is happening with the fragment shader, why it like dies horribly. But it seems like I have broken it more than before, but I don't know. The point is to sell the produce, not that is work. Ah, god damn it, well that looks like horribly broken. But probably one of my lookup tables is still wrong now. So let's move that in our lookup thing. All right. So we have that, and then I think I wanted another potential lookup table. So because that is kind of wrong, right? I think now as well. I mean, yeah, because that's not correct anymore. In my case now. I mean, I could make it like that again. We might look at that maybe. Maybe we do that. Could try to make that go back here. So if we would want to have that, I think I need it up here, right? Yeah. So instead of that, we want not that. I mean, I think I want to have that in the end, but for now, let's not do that. So we go 0, 4, 6, 2. Or probably... let's leave it like that. Worst case, the winding order is wrong. It's fine. 0, 4, 6, 2, yes. And then front face 1, 5, 7, 3. And then if I put that here, then we do 0, 1, 5, 4. I mean, that's maybe too bizarre what I'm doing here, and maybe not worth it at all. So let's do 2, 6. Wait, top. Okay, 6. I don't know, let's do 2, 6. Nah, let's not do that. That's garbage. Let's fix the edges instead. I think it's easier. I think fixing the edges is simpler than doing that crap here. Where's my stream? Yeah, I will look at the Discord after the stream. Then we can discuss. So I had like this map. Hold on. God damn it, where is my other thing? So I wanted this. So that are the edges. Like the new edges. So as you can see, we kind of flipped a little bit the stuff. And base, well, actually we can probably copy that to make the new layout. So this is vertex 0, that's edge 0, and that is vertex 2. And then we have edge 2 and edge 3, and this is nothing here. And then this is edge 1, and that is vertex 1, and this is vertex 3. Yeah. And then with that we get the combination that this is no longer 3, 0, but instead 2, 0. Well, 0, 2 actually. Right, because we go from edge 0 to edge 2. And before it was... Well, hold on. Before it was edge 3 to 0. Edge 3 to 0. Really? I mean, it doesn't really matter, right? Because it's still the same thing. So it doesn't really matter. So let's fix that maybe. I mean, maybe that's more correct anyways, and maybe what I had here was anyways garbage. And then we have 0 and 1. And then we have 3, 0 as like 4. And then we have 3, 2. Which might be... Hold on, what? We have that, and then we have 0, 2, and then we have 2, 1. And then we have 0, 1. And then we have 3, 0, minus 1, minus 1. Don't we have 3, 2? Doesn't make too much sense. Okay, 0, 2, 2, 1, 0, 1, 3, 0, 3, 2, minus 1, minus 1. So that's not the ambiguous case, I guess. The next one is the ambiguous case, which is like 3, 2, or actually no, 3, 1, 2, 0, and then we have here ambiguous, which is case 3. We need to look up that config. I'm not sure what that is currently. And then we have 3, 1, minus, minus, and then we have 1, 3, minus, minus. Then we have 1, 0, 3, 1, 2, which is the other ambiguous. Then here we have 2, 3, minus 1, minus 1. Those are like the lookup cases for the marching cubes, or marching squares actually. 2, 1. Or actually we were here and then we added 2, 3, minus 1, minus 1. And then this is 0, 3. And then here we have 1, 0. And 1, 2. And 2, 0. And then we have minus 1, minus 1, minus 1 again. And then this is ambiguous and this is ambiguous. And the ambiguous case here is 3, 0, 2, 1. And then here it is 1, 3, 0, 2. And we need to fill that out here, so that's no longer here, that's here. Do you have the ambiguous cases here somewhere? I just does it manually or what? Okay. And then here, that's not configuration 10 anymore, right? This is the ambiguous one now. 9. So we will double check that again with the setup of the edges and stuff like that. Not taking that as granted here. That lookup table. Basically, so that's -1, -1, -1. Because we don't have anything here. And then here that is 1, 3, 0, 2. 1, 3, 0, 2. All right. So those two are kind of easy, right? So those are easy, and then 1, 2, 4, 8. 14, 13, 11, and 7 are one edge things. Can I do this and then do that? Because can I then? Yeah, then I can collapse it. Perfect. So that is easy. 0, 2 is edge 0 to edge. Edge 0 to edge 2. So it's this one. Let's leave that one away. So yeah, that's an one edge combination. And then 2 and 1. That's as well 1. We have 3, which is edge 2 to edge 1. Wait, here. So those are configuration 1, exactly. Then we have 3, which goes from 0 to 1. That's a configuration 2, that's correct. Then we have 3 to 0, which is again configuration 1, perfect. And then we have here 3, 2. So 3, 2, that's configuration 2 here. And then we have 3 to 1 and 2 to 0. And that is ambiguous because that's one of those. And that is here number 6. And then this becomes 3 and 5, right? Yeah. And then that makes sense because then we can do either like 3 and 1 and 2 and 0, or we can do 3 and 0 and 2 and 1, exactly. So either we flip it that way or the other way. That makes sense. And then we have 3, 1, which is 3, 1, so that's configuration 1, which is correct. And then we have 1, 3, which is as well another configuration 1. And then we have 9, which is 0 to 3, or 1 to 2. Yeah. And then the ambiguous one would be 1 to 3 and 0 to 2, which is again flipped, so that's correct. And that is configuration 9. So that's 3. And then 2, 3, 2, 3. Edge 2 to 3 is a configuration 2. 10. Then we have 0, 3, which is a 1 edge. 1, 0 is configuration 2. Is that correct? 1, 0, yeah. And then 1, 2. So 1 edge. And 2, 0. 1 edge. Okay, so that looks kinda correct. I'm not quite sure what those comments here are. Because what is 10 duplicated? I think... Wait, is it 1 and 14? So 1 is that 0, 2, and 14 is 2, 0. Oh, that's what it means duplicated, right? So 2 is 2, 1, and 13 is 1, 2, exactly. And then 4 is 3, 0, and 11 is 0, 3. That's mainly because it's mirrored basically. And 8 and 7 are mirrored, exactly. So that's what that means. So 3, 5, 10 and 12. So we have 3, 5, 10 and 11. But 10 and 11 are the mirrored ones. Wait, 3, 5, 3 and 5. And then 10 and 12, sorry. So 2 is 0, 1 and 12 is 0, 1. So that's 12. And then 5 is 10. Right, because 12 is the mirror of 3. and 5, and then 10 is the mirror of 5. Yes. Alright, and then we have here as well mirrored. Nine. Is that the same? Yeah, it is. Alright. Sorry, I was having the chat disabled. Do you by chance know what's the article that described STD vector implementation for games industry? No, I don't. But is there like a special one or what? Did I maybe miss that? Because, for example, in my current company, AAA studio that I work for, they use the STD vector just fine. But yeah, in Anvil and Snowdrop, there were custom implementations for it, but I don't think it's warranted anymore nowadays, but I don't know. People probably disagree because of compile times or something like that. Oh, my vertex map is probably. So Pinky Promise by C++ working group it is. Yeah, I mean, you have to always take it with a grain of salt, but I think there are certain things in the standard library that are fine, in my opinion. And STD vector, I think, is one of them. That's such a core thing that I have my doubts that someone makes it that much better. But yeah, of course, there is maybe use cases where you can make a better implementation. I'm not saying that. But general purpose one, I don't think. I don't think it makes too much sense to make your own. So that one is not used, that one is not used, so maybe we have a working version now. Like, fingers crossed, right? We fixed our lookup table, we fixed our corner edge points, and will probably look exactly like it did before. Oh, actually, slightly better maybe. Hold on. Hold on. Not too shabby. Let's put in our beautiful fallback thing, which I think I have removed again, yeah. Let's just see what happens if we turn around our clockwise order if we think we detected that it's not correct. I mean, almost. Although, maybe not. Do we have a... yeah, we have a big hole here. God damn it. How come that's the case? Sad. But yeah, that is wrong. And then here we have something with the winding order is still busted. Unfortunate. So close and yet so far. Having shared and unique pointers and not having scope pointers is not good by C++ working group. But isn't a unique pointer kind of like a scoped pointer? I will get some water in the meantime while you're typing. So I would argue a unique pointer is a scoped pointer. Or do you have any other definition that you need for a scoped pointer? Mandate scope but does not describe lifetime correctly. I'm confused by that one because the lifetime is described by it all. Because if it goes out of scope, it deletes it. And that's your lifetime. And unless you move it, it doesn't leave the scope. And if it leaves the scope, it is destroyed. Unless you move it. Which extends the lifetime. So I mean, I think I mean, I'm not sure if I agree / follow with the thinking. So would, like, a scoped pointer, would that, like, what's the difference, like, in your definition of a scope pointer and the unique pointer? Like, does the scoped pointer because how does, I mean, yeah, how do I say that? What's the difference in the concurrency and parallel workflow that you describe here for a scoped pointer that you would envision? It's diagram time. Yeah, I mean, those kind of discussions are kind of hard with the text chat, right? Because I bet you have a good reason for the thing that you would want a scope pointer, but so far I've never really come across where, like, a unique pointer is not good enough. As long as you stick to, like, very rigorous, like, how you treat your lifetime and your objects. Probably there's cases where it doesn't work. So I'm curious about that. Where did I take that from now? I will briefly condescend my poor thing here again and cry that it doesn't work there. Let's maybe... I mean, the thing is... Yeah, let's try it, I don't know. Another thing we could try... just to make it easier for now. Although, is that really a thing? Ah, yeah, maybe we do that. But first we try that, which probably doesn't change anything because, yeah, okay, it only busted in more. Perfect. Hold on, did I not have a coordinate here? Was that really a thing? No, right? I didn't miss that. Please tell me now. Oh, I might have had... Oh no, I did. All good, I think. Although let's just be 100% sure and take out that weird hack that we have for the winding order thing. Just to be sure again. But I think that will just make some triangles disappear again. Yeah. But do we have like all the triangles? What happens if I want the half sphere, so basically move that 0 again, move that up, move that in, and now we have like half a sphere, right? I think. Perfect. Now I would be happy if we can do that with RenderDoc and see what we get. And then we will open the chat again to see if my diagram to look at is already done. Let's actually look from here on it. Mesh viewer. I mean, that looks perfectly fine, to be honest. I mean, there are holes here, but not as many as... Not as many as I would have thought it would be. Oh, we don't have a back face, right? So I mean that looks almost correct. We have a like weird. Oh, I mean, yeah, we have like weird overlaps, right? That doesn't make too much sense. I think something is wrong here. For sure. Because we have like weird overlapping triangles here. I mean, that is like garbage up here, for sure. Oh, where was it? Here? Oh, wait. Oh, okay, that's like the back face that I'm seeing here. Never mind. Because I'm thinking through. So I think there is something going on here with like the orientation of triangle, something like that, maybe. I don't know. Let's see, where are we? Where is my chat? Here. Diagram is also editable. Man. Are you sure? Oh, well, it didn't copy the whole link. Thank you, Twitch, for that. Or like actually whoever did the link. Why does that not work? Why is there a comma in there and then it breaks the link? Do I have to remove the comma? No. Something's wrong with the link. Or I'm blind. That might be the other option. But no, I think... I mean, the link looks already kinda weird. Why is there always a comma behind it? It's like so weird. So the link doesn't bring me anywhere. And then if I add the comma, it says it's not a valid link. Maybe I can join a room somehow? Huh, yeah. Why is it not in streamer mode again? Whatever. Yeah, I clicked the link. Oh, that one works. Okay. Cool. Alright, we got it. Close some tabs. Okay, so... I guess. Okay, and then we have a main function. Worker thread. I guess is the WT. Create some objects. Yeah, but wouldn't you move it here? Like your unique pointer, wouldn't you move it into the other thread? To keep it alive, if that's what you want? I I think that's fishy if you would want to keep it alive, to be honest. I think the unique pointer is exactly... It gives you, like, in my opinion, it makes you think more about how you use the object and when to release it and stuff like that. It makes you more strict. You don't have floating objects. Modern OS does not allow memory copies from different threads. I thought I can move a unique pointer from one thread to another. Can't I? Maybe I can't. I mean, I think... No, I would have said that I already tried that and did that. I mean, am I not doing that? Kinda? Well, actually, I'm using my own reference class there, not a unique pointer in this case. I think in the current codebase I don't have an object that is done like that. Or do I? No, I don't think so. I don't think I have an object like that currently. But yeah, in my opinion, I mean, if you say it doesn't work, then it doesn't work. But I'm pretty sure I would have said I did something like that, but I would like pass ownership here. So that it keeps it alive. But why? Can't you write here? Can't you have a future on a unique pointer? Or maybe you can't. Not that I think about it. No, actually you no, I think... You could, right? And then you can move it out of the future. When you're done. I mean, it's a lot of moves, but... I wouldn't know why it's... undefined behavior as long as the future keeps the unique pointer alive, right? Because you're done here and you move it into your future. Your thread ends. It doesn't have the unique pointer anymore. The future has it. And the future lives on the main thread. And that one then has the ownership. Oh. Mm-hmm. Not necessarily. I would probably Stupid co-pilot. How do I do that quickly now? I'm really not a guy. Well, let's use go board. I don't know. Although I'm kinda used to having that one, but whatever. Let's get rid of that. Hello, thank you. Now we have main. And let's get, what did you have here? Oh, god damn it, here. Yeah, kinda. Kinda. Can I copy that? No. Or can I? Is it? Oh, I can copy that. But can't you do instead of that? Can't that be a unique pointer? Like, why does it have to be a shared pointer? Shouldn't that work? And then you have your unique pointer. Where is the output? Where is my output? Here. 42. Oh, God. If I can type, yes, I can add it. It's not that. I thought it. Oh, yeah. C++ is fast. I wouldn't know why that wouldn't work, right? I'm pretty sure I did that in the past already. Creating unique pointers and passing them to other threads. I mean, it of course doesn't work if you exit the scope here before you pass off, before you move this into the future. Then it destructs it, yeah. I would have been surprised if maybe there is an edge case where this doesn't work, right? But so we solved the mystery. At least a little bit. Meaning memory is valid after the return. Oh, okay, yeah, I understand that, yeah. Okay. Ah, you mean it oh, okay, yeah. I understand. It basically makes it sequentially ordered with the lock. So why is my... So where were those weird triangles that overlap? This one here, for example, overlaps. And it's weird that it does. Do we maybe still have wrong faces now here? Oh wait, one thing I wanted to test as well is, first of all, do we enter here is the question. I hope not. No, we do not. Okay. My issue was that I was referencing invalid memory by using explicit moves. Ah. Yeah, okay. Yeah. Yeah, you need some sort of lock or atomic thing probably to sync it. So that the memory is valid, yeah. What did I want to do? Oh yeah, I wanted to remove that weird edge case here. In here. Let's just not do that. Let's just not do that for now. And that's it. Let's see what that does. Well, it's single bit in memory address that is important actually. Usually 49th must be 1 for lock and 50th must be 1 for mutex lock. Okay, today I learned. Today I learned. Do we enter this here? Let's try that. Now let's kill that. No, we do not. Okay. Then the other question is, do we enter that? Where we have an assert, great. Okay, no, we don't even enter that case. So all we do is really just... Wait, hold on, what? Ah, where do we enter any of those two? No. So we really just have easy... Yeah, I mean, it kind of makes sense that we don't have sharp features. Huh? Even though there's no known computer with addressable memory of size 2 by the power of 48. Unknown, yeah. Oh yeah, I read known anyways. Implicit, like my mind already added that. Yeah. 2 by the power of 48. Man, that's... I mean, it's in bytes, but still. I guess it's in bytes. Okay, so we only do this, and then we do the calculate zero crossing. And there's nothing special here. And that is the vertex map which we adjusted, right? So let's put a breakpoint here. So we have phase 0 probably, right? Or which phase are we? Okay, phase 1. And phase 1 is front. So it should be this 1, 3, 5, 7, and we should have only coordinates that differ in X and Y. Okay, yeah, we have only X and Y. And we have this, and then we go up. And then we go down left, well, down right. And then we go right up. Sounds good. Oh, okay. Yeah, I mean, a couple of more years until we have that. Couple more years. Okay, so we have the case is 10. Does that make sense? Well, that's hard to say, right? But we can probably see that by the Hermite data. I mean, that makes sense because we come from 0 to positive. And we have here 0 and here 0. So 0 and 2 are negative and the other 2 are positive. So let's see. So we have vertex 0 is negative and vertex 2 is negative. So we should combine edge 2 and 3. Edge 2 and 3, yes. All adds up so far. I mean, at Ubisoft, at Snowdrop, we already needed 128 gigs, more than 128 gigs to fully generate all the data for the game in memory. I mean, we already threw stuff away, but it basically, I think it was the shader compilation that like almost ran out of 100 gigs of RAM. And now you're wondering, the shader compilation? Yes, because it had to load assets to verify which shaders it needs to compile. And it was a little bit naively written as well, so it didn't help that it was not the best code, to be honest. Okay, so and then we have the interpolated value, which is 0.16, which I guess makes sense. That's really hard to say. No, the shader compilation was CPU, right? But still. I mean, it ran out of CPU memory when it tried to collect all the assets it needed. So corners 0, which is this. And then we plus that with the interpolated value of that. And then V1, which is 0, and V0 is 1. Okay, so we take this one and we interpolate it closer to that one. Is that correct? V0 is 1 and V1 is... Does that make sense? 1 and 0. We are edge 2. Okay, yeah, no, that makes sense. Okay, so that is the correct edge. I think that's your OS dev brain kicking in. Usually the shader compilation happens on... I mean... Yeah, you run the shader compilation. I mean, there's probably some part that runs on the GPU. Like the actual... Although I don't know where shader cross runs, to be honest. I would assume it runs on the CPU and not on the GPU. It's actually interesting to maybe find out. I mean, you can definitely find that out by just running the task manager and see what's happening if the GPU gets busy when you do a shader compilation. But that was mostly that was really just loading assets in the game. Because what Snowdrop had, it was very similar to what Unreal has, where we have like shader graphs. So you need to load the shader graph, build the shader out of it on the CPU, like the code, the shader GLSL or HLSL code, and then pass that to the shader compiler. So it was like an offline process to do that, right? To prepare the game for shipping basically, or like to test. Like a full-blown release build. And yeah, basically you had to load every possible combination of like shader flags with that shader and with other shaders, and like, yeah, it was quite a lot of assets that you had to load. So it was not really the yeah, it was more a platform. It was more platform independent in that case, yes, because the shader compilation itself then was platform dependent, but it didn't matter which platform you built, because like the collecting and finding all the possible materials and shaders was the thing that killed it. But again, it was like very naively written. I think it collected, we added then a step that it collected only up to a certain amount and then compiled them, and then threw that away and loaded different chunks of the word. But at the start it was basically loading everything it found, which is horrible. But I mean, it was only meant to run on build machines, so nobody really cared. But yeah. Okay, so we have corners V0. Let's actually do watches for that, because I am confused. Ah, god damn it. No. Corners. Isn't that a thing? Oh, god damn it. Man, I hate that I did that, but okay. Alright, so we have that, and then we have the interpolated position, which is closer to V1, which makes sense because V1 actually maybe it doesn't make sense. I mean 15%. We move 15% closer. From V0 to V1. Does that make sense? Probably, right? Because the other way around. Doesn't really make sense. So probably that's fine. Although, hold on. Do I even support that? Do I have a... I have a... That's new to me. I didn't know that I have that overload, but I mean, I guess it makes sense. It's funny that I write it here the other way around. Doesn't really make sense to do that, but okay. Then the normal. Yeah, that one is not normal. Oh, that might be actually a problem, right? Shouldn't we normalize that normal? If we do that, we should normalize it. Otherwise, that doesn't really make sense. And then again, I don't think... I mean, that's not really the issue anyways. It's like let's see, where do we have ourselves now? So it's H3. And we combine for H3 vertex 2 and vertex 2 and vertex 3. Vertex 2 and vertex 3 on H3, yes. And for that, we again have hopefully the right corners and everything. So that looks fine. Yeah, that looks basically the same, right? Let's actually do a security check here. That one we can actually do quite easy. If corner 0 2D equals corner 1 2D, or corner 0 2D equals corner 2, or corner 0 equals corner 3. And now we do another check where we check corner 1 with corner 2. and corner 1 with corner 3, and then the only check that's left is corner 2 with corner 3. And if any one of those is the same, we basically have a problem. Log info problem. So that might be an easy check that we can do. Well, that was quick. Did I fuck up, or did it really catch an error? Well, no, that looks bad. That looks bad. Alright, but that's even in the one that we don't care about. God damn it. God damn it, why would I do that? Let's kill that window. Okay, well, that was weird. Is that a... Okay, no, it's not a 100% crash, good. Okay, so that doesn't happen. So that's not the issue. God damn it, that would have been too nice. Do we ever go... I mean, probably we don't, right? Because we don't have a face sharp feature. So we don't go in here. And then out intersection position. Yeah, that's all useless information here. Okay, so that's not it. It's probably something super stupid. It's probably something super stupid. Let's just be sure and do that. I mean, that doesn't really fix it, maybe? I mean, maybe it does. Let's flip our thing again. There might as well be still that we throw away. What? There was a lot of output. Oh, okay, we flipped the copper. I mean, that's almost good. But then it doesn't really work, right? Because here it flips the wrong things. And we still have some missing triangles. So I don't think, first of all, that the flip is correct, because it clearly destroys some. So I'm not even... don't think that is even correct. I hacked it together. So my assumption is that maybe we still run into this issue, because that would explain if we throw away components, because that should never happen. Okay, yeah. So that is definitely a problem. I mean, that makes sense because I mean we don't need that triangle probably. 0, 5, 3 to 0, 5, 3. How do we even get to that? It's exactly on the surface, okay. On exactly one corner. But shouldn't that... Maybe we need to... Maybe I'm misunderstanding the algorithm here. But that should have no consequence, right? Now we have this, which is probably the same problem. That we have exactly 3 identical vertices because we have exactly 1 sample point. Inside. So we have that 1 times, 3 times, 4 times, 5. We have it a couple of times. If we have vertices 2, does that work? Ah, we could have, right? So let's actually check that we don't have that. Because that would be a problem as well. Okay, so we don't have that. Well, actually less or equals to 2. Stupid me. Let's actually do equals to 2. Because I'm only interested in that case. Okay, so we don't have that. We just have the cases where we have exactly 1 point inside, 1 point outside. And those are probably the cases where we have the missing triangles. Although that would be weird. But maybe not, actually. Maybe that's exactly what this kind of points to. Let's do more samples. And... But I mean, the flipping, still the same thing, right? That our vertex things are not correctly... that they are not like correctly generated. Okay, no, that didn't really. No, hold on. We should flip the thing again to see if we have the holes still, or if they just got smaller. Might as well be that they just got smaller. Then that doesn't really help us. Yeah, okay, they just got smaller. Hold on, what? Is that how I would... That's so weird. Okay, well, I mean... Let's do only 1/4 of the sphere again. It's a little bit bizarre what's happening, not gonna lie. Okay, so that's not it. I had a suspicion, but yeah, it's not it. But the flipping is kinda odd anyways. I don't know if they are missing or... I mean, probably they are missing, to be honest. Oh, maybe they are not missing. Oh, maybe they are missing. I don't know. I mean, that looks perfect up here, right? So it's maybe really just a winding order? Maybe it's just a winding order, but that looks bizarre. But the top half is like picture perfect here, right? I mean, that code is sus anyways. So I wouldn't trust that one at all. Alright, I think I'm too tired to continue, but we got a little bit further. Will be quite some time more until we have figured that one out. But I mean, that's pretty much in line with what I had in mind. Probably that we have to invest a lot of time to make this work. And I'm fine with that because I'm learning on the way. And that's the whole thing behind all of this, that I want to learn this volumetric terrain things And this is a completely new algorithm, and I have absolutely no idea where it's going wrong currently. Except for my suspicion is still that the winding order. Is that now consistent if I turned on the sampler size again? Is the upper half consistently good? Oh, beautiful. Okay, so I think the upper half is correct then. Because I would assume that if I turn down, for example, this to 2, that we get a block. I mean, it's hard to say because we have only a I mean, you can see that it's blockier here, I think, right? The curvature is like a little bit chunkier. Than what we had when we do, for example, 8. Then it was a little bit smoother on the surface. And it takes longer, but I mean, that is obvious. But now if we go closer, yeah, it's like way more like rounded, right? It's not like like a step thing. It's actually fascinating that because our resolution is way. Hold on, that. Yeah, I was thinking in like the terms of Unreal, so our resolution is like way higher now. Anyway, so we can probably do 1 and be fine for now. Oh, I mean, that's interesting. If we do 1, then this looks better. I mean, it's still flipped, right? But that is sus. Why would that make a difference? Launch. Why does that make a difference? That's bizarre. And those triangles look busted as. I mean, we still have these weird overlaps. I don't like that. I don't think this is how it should be. So maybe it's just that with 1, we are kinda lucky that it works. Right. But here we can verify, hold on. Oh god, can I somehow reset that? Okay, yeah. So this one has... Can I not see that? I mean, okay, I can do it maybe here. Damn it. Please. So we go from here to here to here. So that's counterclockwise, right? Well, actually, no, it's not. That's a clockwise order. And then up here we probably go counterclockwise, I would assume. So this is the first one, up, down. That's counterclockwise exactly. And then here. This one is the first one and we go clockwise. Yeah, okay, so that's the problem for sure. So that's one issue. Which probably... It's probably how we link the segments. I think. Maybe. It's either how we link the segments or what we get out. I don't know. I would need to look at that tomorrow. So the clockwise order, counterclockwise order is one issue. And then the overlapping triangles is the other one. Which probably at higher resolution results in these gaps that we have. Because I mean, why is this thing here, right? We have a triangle like that, and then we have a triangle like that. That shouldn't be... And further, like, as well, the sizes of the triangles doesn't really make sense. Because yeah, something's weird. Something's weird for sure. Probably we should look... Maybe I should try to isolate. Because now that we have like way less resolution, maybe I can turn it down to a resolution where it's like super easy and we can see what's happening. That's probably the best idea. Similar to the example we had before with the IMGO, it's just that now we do it with a real mesh. And we check the cube faces and what's happening. Could it be that... But no, we are not entering that function. Oh well, I will look at that. Let's not stress that for now. I think tomorrow, fresh day, fresh mind. And then we will figure one more thing out, I guess. And then we do that every day and we have it done in a week or less. And then the good thing is moving that then to the GPU. Once we have it on the CPU, it's not that hard. Famous last words, but yeah. But yeah, like those triangles are like, this is kind of sus. Because aren't they spanning too much range anyways as well? So this one goes from 2 to 1. I mean, maybe that's like exactly 1 in range. Yeah, I mean, maybe that's like... Yeah, could work out. Alright, well, we will do that tomorrow. Thank you very much for joining. Have a nice rest of your evening. We see each other tomorrow, same time, same place. And hopefully a couple of more fixes. We fixed a lot today. But yeah, still a lot to go. But once everything falls into place, it will be amazing. Thank you very much. Have a nice rest of evening. See you tomorrow. Bye bye.